Hello and welcome to computer programming. So this is sort of our first video. All right, we're going to take a look at variables and calculations inside of C++, and we're going to use those to write a program that allows us to calculate change. So for example, if you had, if you needed 42 cents in change, our program would tell you that 42 cents works out to be 1/4, 1 dime, a nickel, and 2 pennies, right? So that's where we're headed, but we're going to build up slowly. So I'm going to walk you through some stuff. We're going to look at some basics, and then we're going to get down to actually write the program. And we'll write part of it together, and then you'll have to try to finish the rest of it on your own. Now, before we even get started, I want to kind of show you how we're going to be accessing the files in this class. So inside of Google Classroom, you are going to see the assignment. And there's going to be a file attached called intro-making-change.zip. Now, if you're not familiar with zip files, I just want to kind of show you how this works, because zip files are like a really easy way for me to send you a whole bunch of things at once and you not have to download them all separately. All right. So when you click on this, it's going to open this up and it's going to say couldn't preview file. There was a problem displaying the image. And it's going to give you options like open with zip extractor. We don't want to use these. All right. The problem with zip extractor is it's going to save these files to your Google Drive, which doesn't actually help us. All right, we don't want them on your Google Drive, so we're not going to use this. All right, so don't click zip extractor. If you clicked it, just exit out. What we want to do is just straight download this. Now, it's kind of annoying because to download it, you actually have to click on these 3 dots and choose open in new window. Once you open it in a new window, then you will have the download icon. Right, but that doesn't show up in the initial preview window. So again, from the beginning, you click on the attachment, it's going to show you this window. We're not using the zip extractor. We just click on these 3 dots. We say open in new window. And then once it's open in this window, we can hit download. All right. That's going to download the zip file to your computer. All right. Now, presumably it went to your downloads folder. So how do we get to your downloads folder? Down in the bottom here, you should have the File Explorer icon. All right. If you click on this File Explorer icon, and then on the left-hand side, you click on Downloads, you should see that you have this new zip file, Intro to Making Change. And there should be the computer programming folder that we made on day 1. All right. So we need to now unzip this file. So to unzip it, we can right click on it and choose extract all. You can just click extract here. All right. It's going to open it up in a new window. That's fine. No problem with that. I'm going to actually X this out because what you're going to see now is that you've got 2 versions of that folder. You've got one that's zipped up, and you've got one that is unzipped. All right. We don't need the zipped version anymore. So I'm just going to hit delete, or I'm going to send this to my recycling bin, or however you want to do it. I'm going to get rid of that. And then I'm going to drag this into my computer programming folder just to keep myself organized. Like I said, you're going to be getting one of these almost every class. So they're going to build up. So I'm just bringing this one into the folder so that it's all in one spot and it's easy for me to stay organized. All right, once I have this folder in there, then I'm clicking on the icon that says first program. I'm not clicking on this C++ main. I'm not clicking on any of this other stuff. I'm clicking on the one that has the project file next to it. So if I open this up, it should launch it right in code blocks. So give it a second to come on up. And it's going to open it inside code blocks, and you're going to see there's some code in here. All right. Now, if you're not seeing any code, over on the left-hand side here is sort of the Navigator. And there's these different arrows that let you move between the tabs. If you're on the Projects tab and you go down to Sources and click on that little plus sign, there should be a main.cpp. And then if you double click on that, you should be able to see all of the code. All right, so we talked about this a little last time, but the include statements up at the top just include files that we're going to be able to use and access, which allows us to do things like print things out from the screen, take in information from the keyboard, all stuff that's going to be important. Using namespace standard just means we're using a lot of the standard keywords and values, so you don't really have to worry about that. And then int main is where our program actually exists. This is the code that we're going to be running. Right here are some variables, and we're going to talk about those in a little second. And then down here is some code that's commented out. All right, comments allow you to like write in the program, and it's for like human beings to read, but the code itself doesn't get turned into like the ones and zeros that get run on the processor. It's just for other humans to read. The computer isn't going to do anything with what's written inside these comments. And we'll talk about this more when we actually get to the activity. Right now, I want to focus on the variables. All right, so again, variables are how we keep track of information inside of a program. All right, so each of these is a variable that I've created that can keep track of information. And there are different types of variables. All right, today we're just going to focus on integers and floats. So integers, int, are not allowed to have decimals. Float, all lowercase, notice that it's all lowercase there, are allowed decimals. They're called floating points. All right, so whenever you want to create a variable, you have to start by saying the type of variable that you want. So in my case, int, float, and then you have to give the variable a name. All right, so I've given these variables x, y, z, and then answer and decimal. All right, the name can generally be whatever you want, only it can't start with numbers, but it can have numbers in it. So I could say like x2, I could say y2, and they also can't be reserved words. So I couldn't create, like if is a reserved word, so I can't create a variable called if. Generally, if the text is changing colors in this program, then it's a reserved word, which means you can't actually use it as your variable. Now, these first three variables are called initialized because they gave them a starting value. I said int x, and I'm setting it equal to 4. Int y, I'm setting it equal to 2. Float z, I'm setting it equal to 5. These two down here are not initialized, which means they have no value. And what happens is they get assigned a spot in memory, and whatever happens to be there is the value that's currently there. So like if I tried to print out answer, and I did C out answer, I don't know what's going to happen. All right, I don't know what value is going to be printed out. It's going to be whatever happens to be in the memory location that I've assigned to answer. So if I run this right now, and I click and run this, let's see what I get. I might get a 0. A lot of times you do get a 0, but we shall see. And then you can ignore this virus threat protection. I got 8,132,384. Again, no real significance there. It's just when you don't set a value, you have no idea what's going to be inside of that. So most of the times we are initializing it and giving it a starting value. But if you don't, you just have to be aware that you don't want to use it until you've actually put something inside of it, because otherwise you'll just get a garbage result back. All right. Now, notice that in each case, I put the variable on the left-hand side and I put the number on the right-hand side. All right. It would not work if I flipped this around. So if I said 4 equals x, that would not work. All right. We say equal sign, but it's really what's called the assignment operator. And what it's saying is take whatever's on the right-hand side and assign it to the left-hand side. Take whatever's on the right-hand side, assign it to the left-hand side. So if we were trying to write it this way, that would be saying take x and assign it to the number 4. which doesn't really make sense. So again, the variable is always going to go on the left. The value that you're placing in the variable is always going to go on the right. All right, but each of these is a variable, and you can almost think of them as like the let statements in math. So this is saying let there be a variable x and give it the value 4. Let there be a variable y, give it the value 2, so on and so forth. Once we've declared them, we no longer need the ints and the floats and so on and so forth. I can just use x from this point forward, and the program will know that it has the value 4 in it. All right, I can just use z from this point forward, and the program will know that it has the value 5 in it. So what we're going to do before we actually get started on the change program is just show you some of the peculiarities with variables in C++ and working with a mixture of ints and floats. All right, so the first one that I'm going to write here is I'm going to do a little calculation, and I'm going to say answer equals 2 divided by x. All right, now again, notice that I put my calculation on the right-hand side. I put the variable all by itself on the left-hand side. That deals with this assignment operator. I'm saying take this and place it into answer. If I were to try to flip it around, I'd be saying take answer and place it into 2 divided by x, which just doesn't work, and you would get an error. Also notice that at the end of pretty much every line, I have a semicolon. All right, there's going to be a few exceptions to that when we get further in, but for the most part, every line of code is going to end with a semicolon, especially with some of these early things that we're doing. So this is saying answer equals 2 divided by x. And then what I'm going to do is print out answer. And if I run this, so again, if I go to build and run, this little icon right here with the gear and the play sign is the shortcut for that, but you can always just go to the build and run. You're going to see that when I do this, the answer that prints out, again, you can ignore that, is 0. All right, so why is 0 being printed out? Because x is an integer value, answer is an integer variable. So when I do 2 divided by 4, yes, technically it should be 0.5, but answer is an integer variable, so it can't store the decimal, so it just cuts it off, right? It doesn't round it, it just cuts it off. It's what's called truncating. So 0.5 just becomes 0. Now, if I store it inside of decimal, so instead of answer, let me store this inside of decimal. And then instead of printing out answer, I'm going to print out decimal. All right, if I run this one now, oops, again, if that's ever grayed out, it's because you forgot to close this, or more likely I forgot to close it. So let me build and run this again. And you're going to see that I'm still getting 0. Now, why am I still getting 0? All right, because I'm storing it in a float variable. The reason I'm still getting 0 is because these are both integers. All right, this is an integer, 2. X is an integer, 4. So when it does the calculation, it's doing the calculation on 2 integers, which means it uses specific circuits on the chip that can't handle decimals. So it does the division, it gets the answer 0, and it stores it inside of decimal as a 0 because the 0.5 literally doesn't exist. The circuits on the chip that were used don't calculate the 0.5 there, so it just ends up as a 0. It doesn't matter that I'm trying to store it in a float variable, I still get the value 0. Now, if I were to change this to 2.0 divided by x and then rerun it, you are going to see that this time I get the decimal. I get the answer of 0.5. All right? By typing in 2.0 as opposed to 2, it's informing the computer that I need to do decimal calculations. So that's going to give it to different circuits on the chip. So when it calculates it, it is able to calculate the 0.5. And then because I created a float variable, I can actually store that 0.5. Now, if I did the same thing, but tried to store it in answer, the 0.5 would disappear because now I'm trying to store it in a variable that can't actually store decimals. All right, so it's not just a question of where you store it. It's also a question of what's being involved in the calculation. All right, and if the calculation only involves integers, it's going to give you an integer answer regardless of where you're storing it. If the calculation involves a decimal, then it will give a decimal answer, and depending on whether you store it in a decimal variable or in an integer variable is going to reflect whether or not you actually get the result at the end. So what did I want to do next? Oh, so answer 2.0 divided by x, we did that. Next, I want to try, other than 2.0s, the same thing applies if I'm using actual variables. So if I did like z divided by x, z is 5, all right? I didn't type in 5.0, but because z is a float variable, that will automatically sort of invoke the decimal calculation. So it's going to say z divided by x. It's going to recognize this as a decimal. So it's going to do 5 divided by 4. And it's going to give me 1, all right? Because I stored it in an integer variable. If I change this to decimal, which is my float variable, and then I print out decimal, all right? Now it's a decimal calculation being stored in a decimal variable. So now I will get the 1.25 that we intuitively think 5 divided by 4 should be. All right. Now, last thing I want to show you here, because this is where it can get a little tricky, is when you're doing a longer calculation. So what I'm going to do is I'm going to do decimal, and I'm going to do y divided by x times z. Now, y divided by x is 2 divided by 4. So let me just bring up a calculator here. Calculator. All right. So y divided by x is 2 divided by 4. And then I'm multiplying it by z, which is 5. So that should give me an answer of 2.5. All right. And again, here's my float. And I'm storing it in a float variable. So one would think that I should get 2.5. Now, you're probably figuring out by the way that I'm talking that we're not going to get 2.5. But let's talk about why we don't. All right, so there it is. I didn't get 2.5. I got 0. Why did I get 0? All right, what happens is when you do a longer calculation, the computer follows PEMDAS. Please excuse my dear Aunt Sally. So when you have lots of division and multiplication, it just goes left to right. So the very first thing it does is y divided by x. All right, y divided by x is 2 integers. All right, so when it does 2 integers, it does 2 divided by 4 and says, oh, those were both integers. 2 divided by 4 should be 0.5, but I don't deal with decimals, so I'm just going to give you a 0. So it ends up being 0 times 5, which is why I got 0. Now, if I flip this around and instead write it like this, z times y divided by x, in theory, mathematically, this gives me the same answer. So if I clear this out and I do 5 times 2 divided by 4, those both give me 2.5. Only this time when I run it, I'll actually get the 2.5 as opposed to the 0. All right, so why does this one work where the other one didn't work? Well, here, the first calculation involves a decimal. All right, it involves z, which is a float. So when it does the 5 times the 2, it's using the decimal circuits. So it says, okay, that's 10 and it's a decimal number. Then when we divide by the 4, this 10 is a decimal number. So we do 10 divided by 4 and get the 2.5 that's stored in here. All right. So there's just a little sort of trickiness when you're mixing and matching ints and floats because they do behave differently. Now, to be fair, a lot of times you're either using one or the other, right? You're either using int because your calculations specifically are more useful with ints, or you're using floats because you specifically need decimals and want those. So you're not necessarily mixing and matching all that often, but it is important to realize there are implications when you mix and match. And depending on the order in which you write things and depending on how you do use different things, it can give you sort of different results based on how you have it all set up. Okay, so that was just sort of the introduction I wanted to give you to sort of variables, ints versus floats, and just understanding sort of the implications of those different things. So what I'm going to do now is I'm actually going to delete all of this code. All right, so I'm going to highlight this and delete it. And then underneath here, you're going to see that there's this / and a star. All right, that marks the start of my comment. Down below, there's a star and a / that marks the end of my comment. What I'm going to do is I'm going to delete this out, and I'm going to delete this out. So this is now no longer a comment, it is active code. All right, and this is going to be our starting point for our making change program. All right, so what does it have so far? It has a variable called change that can only store integers. It has a message that prints out to the screen that says enter the amount of change 0 to 99. And then this is a little fancier, and you don't have to worry too much about this right now, but this is basically an error check. All right, this is what's called a while loop, and it allows us to repeat code over and over and over again. So this basically says while change is less than 0, these two vertical lines mean or change is greater than 99. We're going to print out the message. I said it had to be between 0 and 99. What the heck? Try again. So this is basically an error check to say that, hey, if somebody types in a number that's not valid, you got to try again. You got to type in a different number because that one's no good. All right. So this is just a way of putting in a little error check so that we can force the user to type in a value that works in our system. So this is just saying, hey, if they type in something less than 0 or they type in something greater than 99, we have to give them an error. All right. So what are we actually going to do? Now, a lot of times when people start programming, the first thing they want to do is sit down and type some code. You know, oh, I'm going to do this calculation. I'm going to do that calculation. The first step really should be to think about the problem and think about what you're trying to accomplish and how you would accomplish it. So if I tell you, hey, you got to give somebody back 35 cents, you can probably pretty quickly go, oh, that's a quarter and a dime. Oh, you need to give back somebody 54 cents. Oh, that's 2 quarters and 4 pennies. Oh, you need to give somebody back 83 cents. Okay, that's 3 quarters, a nickel, and 3 pennies. All right, you can figure that out in your head. The question is, what is the set of instructions we can come up with that will allow a computer to calculate that? All right, because we have to take what we intuitively know how to do and translate that into a series of instructions that the computer can actually follow and work along with. All right, so that's our first goal. Before we even think about what code we have to write, we need to think about, all right, how do I come up with a set of step-by-step instructions that someone could follow to calculate change? All right, forget that it's even a computer right now. Just think, all right, if I was trying to teach somebody how to give out change, what would the process be? All right, how would I tell them how to do it? All right, and that's our first guess. That's our first problem. All right, so that's what I want you to think about for a little bit. And I would actually advise you to pause the video and just think about, all right, how do I calculate change? Like, what does that actually mean? What does that actually involve? All right. So again, pause the video and think about it, and then unpause it, and we'll talk about it a little bit. All right. So I'm assuming you've paused it. I'm assuming you've thought about it. Hopefully you just didn't keep watching the video. And let's talk about kind of some of the approaches that kids usually come up with. All right. One approach is they're like, all right, well, I start subtracting away like quarters. And I say, all right, well, let's say they needed 62 cents back. I subtract away a quarter. And if it's still above a quarter, I subtract away another quarter. And if it's still above a quarter, I subtract away another quarter until I'm at a number less than 25 cents. And then I start subtracting away dimes until I'm above 10 cents. I mean, below 10 cents. And then I start subtracting away nickels until I'm above or below 5 cents. And then I subtract away pennies. So that's usually one approach that kids come up with, is they say like, oh, I would just keep subtracting away things to figure out how many I have to do. And we could write a program that worked that way, where we kept subtracting away 25, 25, 25. But it would actually be kind of tricky to write that. I mean, not tricky, but it would be kind of involved to write that. Right? The other approach that kids usually come up with is division. All right, they say, okay, well, I could divide the number by 25, and however many times it goes in, that's how many quarters I get back. All right, and then I take whatever's left over and I divide that by 10, and whatever number I come up with, that's how many dimes I get back. And then I divide it by 5, and how many times it goes in, that's how many nickels I get back, and so on and so forth. So that's the approach we're going to use. We're going to take the division approach because it's a little bit of a simpler program. All right. So the first thing we need to do when we're writing our program is figure out, or actually let the user type in a number. So we have this message here that says enter the amount of change, but we don't actually let them type it in. All right. To let somebody type something in these console programs that we're going to write, we're going to use cin, which stands for console in. Now, when you're using cin, you don't use the less thans. You instead use greater thans. All right. So you're going in the opposite direction. Right. And then when they type something in, you have to tell the computer where you're storing that information. So what we're going to write here is cin change with a semicolon. And that's basically saying, hey, enter an amount of change and then store that information in the change variable. So whatever they type in is going to get stored in the change variable. Now, once it's stored in the change variable, then we get to this code that actually checks, is it less than 0? Is it greater than 9? And then I say, I said it had to be between 0 and 99. What the heck, try again. So after this try again, we're going to do another cin for change. So basically, we're letting them type it in. We're making sure that it's in between the right values. If it's not, we make them keep trying until they type something in that's correct. And then once they type something in that's correct, we actually will run the program. So if I were to run this right now, all right, it's going to ask me to enter an amount of change from 0 to 99. And if I type in 150, it's going to say try again. If I type in negative 24, it's going to say try again. If I type in 895, it's going to try again. And the program just will not let me proceed until I type in a valid value. And then once I type in a valid value, it ends because we haven't actually done anything yet. All right. But at least now we're taking in the information and we're storing it inside of a variable. Now, once we store it inside of a variable, now we can start doing things with it. So I just said we're going to take the division approach. So the first thing we're going to do is we're going to divide it by 25. So I'm actually going to make a new variable. And the convention is that usually all your variables get made up at the top of the program. I can make a variable anywhere. I could go down here and say int x, but it's generally good programming practice to make all your variables in the same spot. So I'm going to go up here and I'm going to make a variable called quarters. All right, so I now have a second variable called quarters. And I'm going to write a line of code down here that says quarters equals change divided by 25. All right? And this is where that whole integer thing comes in really handy. All right? Because if I do 77 divided by 25, all right, 77 divided by 25, it is technically 3.08. But because my system doesn't handle decimals, I'm only using integer variables, that 0.08 is going to get cut off, and the number 3 is going to be stored in quarters, just like I need it to be. All right, so that is now going to have the information I want in it, so I can print out Cout, and then this is just kind of like formatting, but I'm going to print out the word quarters. I'm going to print out a colon. I'm going to do a space. I'm going to close my quotes because that's the end of my text. And then I'm going to do a less than, and say, okay, now I want to print out the variable quarters. All right. If I'm switching back and forth between text and variables, I can't just put them all together. So I have my output operator and say, okay, I'm outputting text. Now I have another output operator, and now I'm switching over to a variable. All right. And then I could have another output operator and say, okay, now I want to put in a return statement. All right. So that will format it so that it prints out the word quarters, a colon. Then it's going to print out whatever number is inside of here. And then it's going to hit the enter key so that we move down to the next line. Now, if I'm continuing here, I now need to update my change variable, right? Because I divided it by 25, right? That gave me, let's just pretend I had 77 cents. That gave me the 3. But now I need to update it because I've given back those 75 cents. So they're no longer part of my change. So I can say change equals change minus quarters, which is the number of quarters I'm giving back, times 25, which is the amount of money a quarter is worth. All right. So what this is saying is take the old value of change, subtract quarters times 25, and then store that so that it becomes the new value of change. And again, the calculation always has to go on the right-hand side. The variable by itself goes on the left-hand side. So we're doing this calculation, and then we're assigning it to this variable change. And again, this takes the old value, it subtracts quarters times 25, and then saves it as the new value of change. So at this point, we could now continue on and repeat this process. All right, we could do it for dimes, we could do it for nickels, we could do it for pennies, and eventually that would be the total change that somebody needs. So this is the point where I would say, try it on your own. All right, pause the video, stop the video, try it on your own and see if you can finish the program from this point. All right, if you're totally not ready, if you're not ready yet to kind of try it on your own, I will give you a little more. I'm not going to give you the whole thing, but I'll give you a little more just to get started. So if you need this little extra help, the next thing I would say is let's make another variable. All right, so I'm going to make int times. All right, now that I've updated change, I can do times equals change divided by 10. I can then go Cout, print out the word dimes with a colon, switch over so that I'm printing out the variable, and then switch over so that I'm hitting the end key. Now, what you'd want to do next is update this change variable the same way that we updated it, only now we're using the dimes variable instead of the quarters variable, and instead of multiplying by 25, we're going to multiply by 10. But this is all I'm going to give you. At this point, you've got to try to figure it out on your own and get this program working to the point where it will calculate the correct change no matter what value somebody puts in, from 0 to 99. All right, so good luck. Let me know if you have any questions. And when it comes time to submit this project, all right, when you're done with it and it's working and everything's good, what I need you to submit is back in your folder, all right, so back in this Intro to Making Change folder, there is this main.cpp file, all right? This is the file that I need you to upload to Google Classroom. So when you go to turn in the assignment, all right, you're going to upload a file. You're going to attach a file. You're going to upload it. It's going to be from my computer. It's not on your Google Drive, so you're not attaching it from Google Drive. You're uploading it from your computer. You're going to go into this folder, which is in your downloads folder in computer programming, and you're going to attach this main.cpp. It's the source file. This has the code. This is what I need to see to be able to give you credit for the assignment. All right. So I hope that is helpful. Obviously, if you have any questions, you can either hop on a Google Meet or you can shoot me an email and we'll go from there. All right. Have a great day, and I will see you when I see you. Bye.